Another methods of integration is integration by parts. Now for these methods, we have our general formula. We have the integral of u dv is equivalent to uv minus the integral of v du. So this is our main formula for integration by parts. We have our first example. We have 3x is square root of x plus 2 dx. If you have noticed, we have two groups of integrand. First group is 3x and then the other group is square root of x plus 2 dx. So for this case, we have to decide what will be our u, what will be our dv. So let our u is equal to 3x, so that the remaining integrand will be our dv. So our dv is equivalent to x plus 2 raised to 1/2 dx. And then we take the derivative of our u, du equals 3 dx. For dv, we integrate both sides so that the integral of dv equals v, and then the integral of this one, let u equals x plus 2, derivative of x plus 2 equals dx. So this is u to the n. Our n here is 1/2. U to the n du equals u n plus 1 over n plus 1. So this becomes 3 over 2. X plus 2 raised to 3 over 2 over 3 over 2, or that is equivalent to 2 over 3 x plus 2 raised to 3 over 2. Okay, when we apply our u dv, that is equivalent to u times v. We have u times v. So if we multiply 3x by 2 over 3, we cancel 3. So what remains here is 2x and then this one. So 2x and then x plus 2 raised to 3/2. That is u times v minus the integral of v du. V du. So 2/3 times 3, so we cancel 3. So what remains here is 2 times this one times dx. So I will write here 2 and then x plus 2 raised to 3/2 dx. So this one is u to the n. Our u is dx. I mean x plus 2, derivative of x plus 2 equals dx. So that our answer is 2x x plus 2 raised to 3 over 2 minus 2. This becomes x plus 2 raised to 3 over 2 plus 1, that is 5 over 2 over 5 over 2 plus c. So our final answer is 2x x plus 2 raised to 3 over 2 and then minus 4 over 5. 2 times 2, that is 4 over 5. X plus 2 raised to 5 over 2 plus c. This will be our final answer. Now what if you interchange the value of u and dv? So for example, our u equals x plus 2 raised to 1/2, and then our dv is equivalent to 3x dx. Suppose our u is this one, square root of x plus 2, and then our dv is 3x dx. So what will happen if this is the case? So by taking the derivative of our u, that is 1/2 x plus 2 negative 1/2 dx. And then if we integrate this one, that becomes v is equal to 3x squared over 2. If you have noticed this one, the exponent is increasing for x. Originally, you have here your x raised to 1, then in this case, x raised to 2. In other words, the exponent is increasing. So if we continue this one, uv minus integral of v du, we cannot find the final answer. Okay, so what we did is to change the value of u and dv. The main reason is the exponent for x is increasing. So we will not find the final answer. Okay, so you have to change your u dv. Okay, so we will not continue this part. Instead, we will be using u dv, u as 3x, and then dv as x plus 2 raised to 1 half dx. Notice this one, our x is 1. When we take the derivative of x, you have here x to the 0. That is why we only have here 3. Okay. Another example of integration by parts is integral of e to the 2x cosine 3x dx. So again, we will decide what will be our u, what will be our dv. So for this case, I will decide my u as cosine 3x, so that dv is equivalent to e to the 2x dx. And then the derivative of u, derivative of cosine is negative sine 3x, and derivative of 3x equals 3, so negative 3 sine 3x dx. And then the integral of dv equals v integral, that is 1 half e to x. So that when we integrate this one, u dv equals uv, so u times v, that is 1 half e 2x cosine 3x minus v du. So this is negative. So negative 3 and 1 half, 3 over 2, negative 3 over 2 times negative, this becomes positive 3 over 2 integral of e 2x sine 3x dx. That is u times v du. You have your v du, so v du. Negative 3 times 1 half, that becomes negative 3 halves, times the negative, that becomes positive. Now if you have noticed this one, this is e to the 2x sine 3x, so this is another group. This one is, we have here e to the 2x, and then another group is sine 3x. So again, we will apply another integration by parts. So our u, for this case, we have sine 3x, so that our dv is equivalent to e 2x dx. And then the derivative of u equals derivative of sine equals cosine 3x times 3, that is 3 cosine 3x dx. And then the integral of this one, v, equals 1 half e 2x. So that we have 1 half e 2x cosine 3x plus 3 over 2 times the integral of this one equals u times v, that is 1 half e 2x sine 3x, 1 half e 2x times sine 3x, that is u times v, minus v du, minus v du, that is 1 half times 3, that is 3 over 2, integral of e 2x cosine 3x dx. So we will distribute. I will write this one first. Integral of e 2x cosine 3x dx, that is equivalent to this one, 1 half e 2x cosine 3x plus 3 times 1 over 4, 2 times 2 4, that is 3 over 4 e 2x sine 3x minus 3 times 3, 9 over 4, and then that is the integral of, okay, integral of this one, I will write it again, e 2x cosine 3x dx. Notice this one and this one, they are identical, e to the 2x cosine 3x dx. So what we will do here is to transfer this one to the other side. That becomes 9 over 4 integral e to the 2x cosine 3x dx. This one, transfer this one to the other side. That becomes, this is negative, so it becomes positive when you transpose it to the other side. And then we have this one that is plus integral of e 2x cosine 3x dx. That is equivalent to, I will just copy here, 1/2 e 2x cosine 3x plus 3/4 e 2x sine 3x. Now what will happen to this one? Of course, we will combine these two equations, these two integrand. You have here 9/4 plus 1, that is 4 times 1, that is 4 plus 9, that is 13/4. When we combine these two integrand, you have here e 2x cosine 3x dx, which is equivalent to 1/2, and then e to the 2x cosine 3x plus 3/4 e 2x sine 3x. This time, this 13/4 will be transferred to the other side. So you will have a multiplier of 4/13 to the other side. If we transfer this one to the other side, that becomes 4/13. That will be our multiplier for this one. So we will erase this 13/4 because we already transferred this one to the other side. That becomes 4/13, so that our final answer for e 2x cosine 3x dx, because this is our problem. Okay, so 4 divided by 2, that is 2/13 e 2x cosine of 3x plus this one multiplied 4 cancel, that becomes 3/13 e 2x sine 3x plus c. That will be our final answer. We have another example for integration by parts, integral of x squared e to the 3x dx. Okay, so we have to decide what will be our u and then what will be our dv. So our u again is x squared. We will decide x squared as our u, and then dv is equivalent to e 3x dx. So that when we take the derivative of u, du equals 2x dx, and then if we integrate this one, v equals 1/3 e 3x. So that when we integrate this one, I will write x squared e to the 3x dx, that is equivalent to u times v. We will multiply u and v, that is x squared over 3 e to the 3x minus v du, minus the integral of v du. So I will write first 2 times 1/3 integral of x e 3x dx. Notice this one, this is x, and then this is x, e to the 3x. So again, we will apply integration by parts for this part. So our u equals x, our dv is equivalent to e 3x dx, so that our du equals dx, and then our v equals 1/3 e 3x. Okay, so we have x squared over 3 e 3x minus 2/3 times the integral of this one. This is u dv equals u times b, so x over 3 e 3x minus v du, so 1/3 integral of e to the 3x dx, so that our answer here equals x squared over 3 e 3x minus, if we multiply this one, 2x over 9 e 3x, negative times negative, that becomes positive. Okay, 2/9 And then this one is let u equals 3x du equals 3. So we have here an 1 over 3 e 3x. So that our final answer is x squared over 3 e 3x minus 2x over 9 e 3x plus 2 over 27 e 3x, of course, plus c. This will be our final answer for integration by parts. Now, for this process, we can make use of other way of solving integration by parts using the shortcut method. Okay, what is the shortcut method? So we have to decide what will be our u and then what will be our b. So this one is another way of solving integration by parts. We have our u, we have to select what will be our u. Again, we have x squared and then our dv equals, okay, sorry, so our u, our dv. So this is under column u, which is x squared, and then our dv is equivalent to e 3x under column dv. So under column u, we have to take the derivative. Derivative of x squared equals 2x. Derivative of 2x equals 2. Derivative of 2, that is 0. On this part, we integrate. We have integral, that is 1/3 e 3x. Integral, that is 1 over 9 e 3x. Integral, that is 1 over 27 e 3x. And then, using this first variable, combining the second variable of your dv, you have this one. Okay, usually plus, minus is an alternate, plus, minus, and so on. So that we will combine this one. If we combine x squared times this one, that becomes x squared over 3 e 3x plus this one times negative of 1 over 9, that is negative 2x e 3x over 9. We will just multiply 2 times this one, and then this is negative, plus 2 times 1 over 27, that becomes 2 over 27 e 3x, of course, plus c. So if you have noticed, they have the same answer, minus 2x over 9 e to the 3x plus 2 over 27 e to the 3x plus c. Okay, they have the same answer, plus c. So when do we use this shortcut method? Of course, first condition is your u, when you take the derivative of your u, it must arrive to 0. Try to look at this one, x squared, 2x, 2, and then 0. So take the derivative, then you will arrive to 0. So that is the condition wherein you can use this shortcut method. And then for your dv, it must be integrable, or you must the integral can be integrated. Okay, so I will be using the word integrated. Can be integrated. So these are the conditions. If your u, if you take the derivative of your u and if you will not arrive to 0, then you cannot use this shortcut method. On the other hand, if you cannot integrate your dv, then you cannot use this shortcut method for integration by parts.